pull out the key insights so you get informed fast. Today, we're setting off on, well, a pretty extraordinary journey into the mind of Albert Einstein, you know the name, of course, and his impact. It's everywhere. From lasers, GPS in your phone or car, even things like driverless cars, space travel, it all links back to him. But our mission today, it isn't just to recap the greatest hits. We want to go way beyond those famous photos and stories. We're going to uncover some, frankly, surprising and deeply human insights from primary sources that have only recently come to light. We're talking Einstein's own raw notes, his private calculations, really candid letters, even his day-to-day reflections.
Exactly. And then that's why digging into these direct, sort of unedited materials is so important, so profound, really. They give us this completely unparalleled look into how Einstein actually thought. It's a window not just into, his obvious scientific genius, but also his personal struggles, his very particular sense of humor, and that relentless quest that really drove his final decades, especially his search for a unified field theory.
Okay, so let's start unpacking all of this. There's been quite a buzz recently about new documents surfacing. For instance, the Hebrew University of Jerusalem's Albert Einstein archives, they recently put 110 new manuscript pages on display, many never seen before. And it's quite poignant because, well, Einstein himself left his personal and scientific papers to the university.
Precisely. These archives are just gold mines, really, each one holding different pieces of his story. Take the Harry Ransom Center at UT Austin. They've got 4 boxes, nearly 1.7 linear feet of handwritten stuff, typescripts, letters. It spans from 1906 right up to 1979, though most is from that core period, 1906 to 55. And it's in English, German, French. Quite a mix. You can literally see his handwritten work with his own corrections for something like Über die Grundbegriffe der Physik, or even his own copy of his popular relativity book, Gemeinverständlich, which is filled with his notes in the margins. Plus, there's loads of personal letters, like 46 letters with Gustav Bucky, 56 with Maurice Solavine over decades.
Wow. But it sounds like some of the most maybe revealing insights come from things even less formal than these cataloged archives. You mentioned his working sheets. What secrets do these rough, kind of unpolished notes hold about how he actually thought day to day?
Well, that's what's fascinating. These working sheets, they're a huge collection of unidentified calculations, so scratch paper, basically. They document what he was scientifically obsessed with for the last 30 years of his life, right up until he died in 55. And how they were found is amazing. They literally fell somewhere behind the filing cabinets when his papers were being packed up in 1982 to go to Jerusalem. Just found them back there.
No way. Behind the cabinets.
Yep. And we're talking a lot of paper, about 1,800 pages across 2 microfilm reels. And the thing is, most of them are still unidentified, uninterpreted, largely unknown territory. But the good news is, we now have these high-quality 600 dpi color scans becoming available. So finally, we can start to really analyze them.
So this isn't just about reading the final published papers. This is a chance for us, for you listening, to get direct insight into his unfiltered thinking, including what scholars call his unsuccessful paths, the dead ends, the detours.
Right.
It's seeing science as it actually happens. Even for a genius, it's often this long, winding road, not just aha moments.
Absolutely. It's messy, iterative work.
And these raw sketches, they give us this amazing window into his biggest lifelong scientific challenge, don't they? That constant search for a unified field theory, trying to link gravity and electromagnetism. It obsessed him for decades. You can almost picture that famous photo, Einstein and his blackboard full of equations.
Yes, that photo. And when you look at it, knowing his quest, it really shows what he was likely working on in his final days. At the core is something called the metric tensor, usually written as G or sometimes I dot. Basically, it's the math he used to describe the shape of spacetime. Think of G for curved spacetime, where gravity bends things, like drawing on a sphere. And I is for flat spacetime, like a normal piece of paper, where standard geometry works.
Okay, so curved versus flat spacetime.
Exactly. And to make the calculations, which were incredibly complex, a bit easier, he often used something called tetrads. You can kind of picture them as setting up little local coordinate systems, 3 space directions, 1 time direction at every point. They're simpler to handle mathematically than the full metric tensor. It was a way for him to, well, rewrite general relativity in a different, maybe more practical language for calculation.
Right. And on that specific blackboard, his goal was what? To compare something?
Yeah, he was comparing the degrees of freedom. That's essentially the number of independent values you need to describe the system. He was comparing that number in the standard metric version of general relativity versus his tetrad version.
And what did he find? Or what was he trying to show?
Well, it looks like the work on the blackboard suggests the total number of degrees of freedom stays the same, whichever way you formulate it. Meaning the fundamental physics isn't changing, it's just, well, the complexity is sort of packaged up in different places, mathematically speaking.
Interesting. So the underlying reality is the same, just described differently?
That seems to be the idea he was exploring. It points to this deep belief he had in the consistency of nature's laws, however you express them.
And it's also kind of funny, you pointed out his relaxed notation on the blackboard, not always following his own rules, rubbing things out.
Yeah, it's great, isn't it? It suggests this wasn't for publication. It was either rough work for himself, or maybe he was explaining it informally to someone. It shows the real, sometimes messy process.
And this connects to something more formal, but still unpublished, the Washington manuscript.
That's right. A really interesting piece from 1938. It's a 12-page manuscript, written in his own hand, though typescripts exist too, and it's titled simply Unified Field Theory. Remarkably, it's the only document we know of where he used that title without any qualifiers.
Just unified field theory. Bold.
Very. And how it ended up in Washington is a nice little story. His friend, Elias Avery Lowe, paleographer, suggested he deposit it with the Library of Congress, possibly as a sort of gesture of thanks to the U.S. while Einstein was becoming a citizen.
So what was different about this manuscript compared to papers he did publish on the topic around that time?
Good question. The core physics was actually quite similar to a paper he published with his assistant, Peter Bergmann. But the approach, the starting point, was radically different. Instead of building on earlier work by Kaluza, he built this theory from the ground up based on just three axioms, three fundamental assumptions.
Okay, what were they, roughly?
Well, first, he assumed a five-dimensional space with a standard kind of geometry. It was called Riemannian. Second, he required that the fifth dimension be compactified, basically, curled up or periodic. And third, he postulated that through every point, there's a unique, smooth, closed path, a geodesic. And he noted that these three axioms alone completely define the structure. It really shows his ideal. Physics built on the fewest possible assumptions. Oh, and he also put the math appendix right into the main text. He preferred that structure, apparently.
Fascinating. And didn't it end with a kind of challenge?
It did. A very telling final sentence, he wrote. Further investigations will have to show whether it contains a theory, free of statistical elements, of elementary particles, and of the quantum phenomena.
Ah, free of statistical elements. There's his issue with quantum randomness again.
Exactly. And that challenge, finding particle-like solutions within this five-dimensional theory, solutions that didn't rely on statistics or probability, that's precisely where it failed. And that struggle, trying to make it work and ultimately abandoning it, is documented extensively in those unpublished working sheets we talked about.
Wow. So the working sheets really show the why behind the published work, or lack thereof.
Precisely. They show the dead ends, the reasons why certain approaches were dropped. You don't get that full picture just from the final papers.
Yeah.
It's crucial for understanding his scientific journey.
It really brings the human struggle into focus,
Wow.
which is a good place to shift. Let's talk more about Einstein the man, beyond the physics. These documents really open that up too.
They absolutely do. For instance, there are those 4 letters that recently came out, written in 1916 to his lifelong friend, Michel Lebesso. In 3 of them, he's buzzing about his glorious idea on how atoms absorb and emit light. That was the idea that much later became the basis for lasers.
Incredible. But then there's the 4th letter to Besso. Quite different, right? A really candid admission.
Oh, yes. He basically confesses that after thinking about it for 50 years, he still doesn't understand the quantum nature of light, the very thing he won a Nobel Prize for.
That's stunning honesty from someone like Einstein.
It really is. And it ties into his famous line, God does not play dice. People often misunderstand that. He wasn't just dismissing quantum mechanics. He felt it was incomplete. He was looking for some deeper, deterministic process underneath the apparent randomness of things like particle emissions.
Even though his own work was fundamental to quantum theory.
Exactly. It's a huge paradox. His paper on stimulated emission was crucial for quantum physics. Yet he himself couldn't fully accept his probabilistic foundations. Maybe that deep conviction, that search for determinism, actually held him back from fully embracing the quantum revolution happening around him.
The letters to Besso also show his wit, his personal side.
Oh, definitely. He teases Besso, who had converted to Christianity, saying something like, "You will certainly not go to hell even if you had yourself baptized." Just gentle ribbing between friends.
And he poked fun at himself, too.
Yes, about his own Jewish identity. He says, you know, as a Goy non-Jew, you don't have to learn Hebrew, but I, as a Jewish saint, should be ashamed. I know almost none of it. Then he adds, but I prefer to feel ashamed than to learn it. Classic Einstein humor.
That's great. And there's another major source for understanding his later life, right? A diary.
Yes, absolutely extraordinary. The Diary of Johanna Fantova. She was a close friend, librarian at Princeton, and she kept a journal chronicling Einstein's day-to-day life, his thoughts, conversations, for the last year and a half of his life, October 53 until he died in April 55. So it's 62 pages, German manuscript, over 200 entries. Her stated goal was to cast some additional light on her understanding of Einstein, on Einstein the humanitarian.
And the details in there are just so vivid and, well, human. What stands out?
So much. You see his real bitterness about the McCarthy era, the whole Oppenheimer hearing, how that affected him. His very blunt opinions on other physicists come through, too. He apparently called Werner Heisenberg a big Nazi.
Yeah.
And noted age bore was nice, but talked constantly.
Ah, no holding back.
Not in his private conversations, it seems. He describes himself politically as a revolutionary, even a fire-belching Vesuvius, and he admits feeling partially responsible for the creation of the atom bomb, saying that responsibility really weighed on it, oppressed him greatly.
That's powerful. What else? Any lighter moments?
Oh, yes. Despite complaining, all the maniacs in the world write to me. He apparently answered many letters from strangers with real openness and curiosity. And then there's the parrot. He got a parrot named Bibo as a birthday gift, sent through the mail. Can you believe it? Through the mail. A parrot. Apparently so. And he got really attached to it, even told it jokes.
That's wonderful. Just these little humanizing details. The parrot, the jokes.
Right. And his love for sailing, even though he couldn't swim and hated life jackets. But he'd be out there analytically calculating the smallest movement of air on the water.
The physicist sailor.
Exactly. And he had this self-aware humor about his own fame, too. He quipped once, "I only wrote a tiny book about my theory of relativity, and it brought about a scientific revolution." Said with a bit of a twinkle, you imagine.
You really do?
So all these things, the letters, Fantova's diary, they give us this much richer, more complex, deeply human picture of Einstein. It goes so far beyond just the scientific achievements. We see the man, the friend, the person grappling with the world around him, not just the intellect.
What an amazing journey this has been, digging into Einstein's world like this. We've seen how these documents, just recently revealed from calculations on blackboards, those private manuscripts on the unified field theory, to the really candid letters and daily diaries, they just open up this incredible window into both his scientific genius, sure, but also his complex humanity.
Mm-hmm. And it really drives home how much insight you gain from seeing the process, not just the final results. Seeing those unsuccessful paths, hearing his personal thoughts, knowing the questions he wrestled with right to the end. It's incredibly valuable. And it's striking how even his unfinished work, his struggles, continued to push physics forward, continued to inspire people.
It really does make you think, doesn't it? What other hidden details might still be tucked away in archives somewhere waiting to be found, not just about Einstein, but other great minds? How might those future discoveries change how we see their legacies? And maybe even change how we see our own human potential?